All right, pre-algebra. So we are going to be working through the last section in chapter 11, cube roots today. So instead of square roots, we're talking about cube roots, okay? We're going to start off with defining cube roots. So a positive, you can write the word positive, I'm just going to do that. A positive real number has two square roots. One is positive and one is negative. A number is a perfect cube if it is the result of cubing an integer. That means multiplying that integer by itself 3 times, okay? So here we have an index. When we put a 3 in front of the radical, that 3 is what's known as our index. When we do a square root, we would say the index of the square root is 2. We just don't write the 2, but that would be the index right there. You can have a fourth root of something. You can have an nth root of something. We're not going to deal with any of those. We're just dealing with square roots and cube roots. So the 3 is your index, okay? The 8 in our example here, again, we've defined this before, but this is our radicand. And then, of course, we have our radical sign. So when we take the cube root of 8, the answer to that is 2. Okay, the answer to that is 2. 2 is the cube root of 8. All right? Because if I go 2 times 2 times 2, I end up with 8. 2 cubed. Okay? Two main differences between cube and square roots. Number 1 is any real number has only one real cube root, whereas a square root has both a positive and a negative, okay? And we can take the cube root of a negative number. So number 2, the cube root of a negative real number is a negative real number, okay? Remember, we cannot take a square root of a negative real number, but we can take a cube root of a negative real number, because if we go negative times negative times negative, we end up with negative. Okay, so the cube root of a negative number is negative. The cube root of a positive number, okay, is positive. All right, example number 1. What is the cube root of 125? What do we multiply by itself 3 times to get 125? 5 times 5 times 5, 5 cubed. So the cube root of 125 is 5. What is the cube root of negative 216? What do we multiply by itself 3 times to get 216? 6 times 6 times 6. It is negative, so the negative 6 times negative 6 times negative 6 gives us negative 216. So the cube root of negative 216 is negative 6. Example number 2. Okay, example number 2. We are not going to do, just like with the square roots, we're not going to do the estimating to decimal places of square root or of cube roots, but we are going to try to figure out between which consecutive integers cube roots that are not perfect cube roots lie between. So we won't do the estimating part, but we will do this consecutive integer idea. So let's look at A. Cube root of 70. So we need to think of what cube roots does 70 lie in between. What are the perfect cubes? Now I understand you have not memorized those yet, but you will get more and more familiar with these as you work through them. So let's just think of 2, okay? What is 2 cubed? 2 cubed is 8. What's 3 cubed? 3 cubed is 27. What is 4 cubed? 4 cubed is 64. Oh, we are getting much closer to 70 now, okay? 5 cubed, we already did a spoiler alert for that one in the last example. 5 cubed is 125. So cube root of 70 is going to lie in between 64 and 125, right? So the cube root of 70 is going to lie in between the cube root of 125 and the cube root of 64. And the consecutive integers then that the cube root of 70 will lie in between will be 4 and 5, because the cube root of 64 is 4 and the cube root of 125 is 5. So between what two consecutive integers does the cube root of 70 lie? Between 4 and 5. Okay. Now, B, cube root of negative 5. Between which two consecutive integers does the cube root of negative 5 lie? Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So, the cube root of negative 5 thus lies in between the cube root of negative 8 and the cube root of negative 1. So what integers does it lie in between? Negative 2 and negative 1. So the cube root of negative 5 lies in between negative 2 and negative 1. Box skill check number 1, okay, just says find the following perfect cubes, right? Number 2, negative 7 times negative 7 times negative 7, that is negative 343. Okay, if you want to check number 1 on that one, you should get 1,728. Okay, number 3 says find the following cube roots. What is the cube root of negative 1,728? Okay, what I want you to do with as you're getting more familiar with cube roots and perfect cubes and those sorts of things, again, you're way more familiar with square roots, but think about ones that you do know. Okay, what would 10 cubed be? 10 times 10, 100. Okay, 100 times 10, 1,000. So if we're talking about the cube root of negative 1,728, we know we're talking about a perfect cube that is larger than 10, or negative 10 in this case, okay? So you can try negative 11, you can try negative 12. Spoiler alert, the cube root of negative 1,728 is negative 12. Negative 12 cubed is negative 1,728, okay? How about number 4? What is the cube root of 512? Okay, remember up in example number 2, 5 cubed was 125. 512 is obviously bigger than 125. Try 6 cubed, try 7 cubed, okay? 8 cubed is actually 512. 8 times 8 is 64. 64 times 8 is 512. So the cube root of 512 is 8, all right? Then number 5 and 6 say find the consecutive integers between which the following cube roots lie, okay? Look up here at what I wrote down for some perfect cubes. 4 cubed is 64, which means negative 4 cubed is negative 64, okay? So we know negative 70 is really close to that, okay? All right. Then 5 cubed is 125, so negative 5 cubed is negative 125. So the cube root of negative 125 and the cube root, whoops, why did I do that? I'll just do that. The cube root of negative 64, cube root of negative 70 is between negative 125 and negative 64, which means the cube root of negative 70 lies between consecutive integers negative 5 and negative 4, okay? No estimating, all right? Now, continuing on in this lesson, we need to remind ourselves of the product law for roots. For all a that is greater than or equal to 0 and all b that is greater than or equal to 0 with n greater than 0, the nth root of a times the nth root of b, so the indexes have to be the same, is equal to the nth root of a times b. So that's why we can do that with square roots. We can also apply that with cube roots. So example number 4 says simplify the cube root of 2700. So we're going to write this radicand as the product of its prime factors, okay? Which, if you prime factored that out, you'd get 2 times 2 times 3 3s times 2 5s. Now, when we are looking at cube roots, we're now looking for triples, not pairs. So that's going to simplify. That's going to be 3 cubed. What's the cube root of 3 cubed? Well, that's 3, right? So we're going to end up here with 2 2's. So we have the cube root of 2 times 2 is 4, times the cube root of 3 3's is 3, times the cube root of 25, 5 times 5, okay? Because these have the same index, we can multiply. We can multiply the 4 and the 5 because they're both cube roots. So that 3 stays outside the radical, and we end up with the cube root of 100. So simplifying the cube root of 2700 yields us 3 times the cube root of 100. Example number 5, what is 7 times the cube root of 1080? Prime factor 1080, I am not going to do that right now. When you factor tree that guy out, 1080 is 3 2's times 3 3's times a 5, okay? So we end up with 7 times the cube root of 2 cubed is 2. The cube root of 3 cubed is 3. And then we have this lonely cube root of 5. So 7 times 2 times 3 is 42 times the cube root of 5. And you're all done. Okay. Box skill check number 2, we're not doing 1 and 2 because it's estimating cube roots to the 10th. We're not bothering with that. Number 3, okay, is the cube root of 200 when you factor tree out, okay? Factor tree 200, okay? 4 and 50. 50 is 5 times 10, which is 2 times 5 times 5, and this is 2 2's, right? So we end up with the cube root of 3 2's times 2 5's. Cube root of 2 cubed is 2 times the cube root of 5 times 5 is 25, okay? 3,000 over here, 3 times 1,000, 3, we've got 100 times 10, 2, 5. I am doing this really the long way. I shouldn't do it this long, but it's okay. 2 and 2, 5 and 5, 2 and 5. Yikes. Bring it down here, and we get the cube root of 3 3's, sorry, 3 2's, 1 3, and 3 5's. Okay. Cube root of 2 cubed is 2. Cube root of 5 cubed is 5 times the cube root of this lonely 3 gives us 10 cube root of 3. So the cube root of 3,000 simplified is 10 times the cube root of 3. And that is the end of chapter 11.